Ergography is the technique to find out the working efficiency of the human muscle. These are the practicals included in the human in the CBNE curriculum. In the technique of recording of muscle efficiency, the important instrumentation that we require is the muscle ergograph. In this instrument, we are having with this muscle ergograph, which are having with different parts. These parts are the clamps or the curved plates for holding the forearm properly or fixed in this instrument. Then we are having with two metal tubes for keeping the fingers by this way. In one tube we are putting the index finger, and in another tube we are putting the ring finger. Then we are holding the string by the middle finger, and by this way we perform the activity. Then this string is continuous with the movable plate. This movable plate is moving like this, and another end of this movable plate is attached with the another string, which is going over to pulley and applied to the weight hanger, and this is the weight applied. So during the activity we are pulling the weight, and that's why muscle is doing work. So after performance of work, up to how much extent we can perform the work is traced by the muscle ergograph. Second thing, we can study about the muscle fatigue by performing this, and which are the different factors that are applicable for creation of the muscle fatigue. So I'm showing you demonstration of this. So we are fixing the forearm by this plate. This is the way of fixing the forearm. Then we are asking the subject to put this index finger and the ring finger in the metal tube. Then we are applying the string to the middle finger. We are selecting middle finger because it is quite long and having more strong than other fingers. Now you can see the way of recording of the graph, how recording is traced onto the paper. So by this way, this ergography is recorded. We are recording ergography by three ways. One is, this is the continuous recording of the continuous work, where we are asking the subject to perform the work by muscle. Then after some time of the continuous work, initially we get rectangular shape of graph, and later on when performance becomes weak, then it starts less height of contraction, and that is producing a triangular part into the recording, and at last with complete fatigue there will be no performance. This will be the type of graph of the continuous work. In another graph, we are applying this cup of BP cup to the arm for the purpose of venous occlusion. So second graph we are producing of the venous occlusion, in which we are applying the BP cup and increasing the pressure up to 40 mm of mercury, by which veins will get occluded. Due to venous occlusion, what happens to the muscle is there is no washing out of the as blood flow is stopping. That's why no removal of waste by the venous blood is taking place. Waste remains accumulated near the muscle, and that's why muscle performance decreases than the continuous work. That shows the accumulated waste products are hampering the muscle work, and because of that, the length of produced graph of venous occlusion will remain short. Then another graph we are producing is about the intermittent work. In the intermittent work, we are tracing the graph for 30 seconds. Then we are allowing the subject to rest for 2 minutes. Then again we are asking the subject to perform the work for 30 seconds. After 30 seconds, we are again allowing the subject to take rest. So this rest work will show you the pattern or graph that is called as the intermittent work graph, in which subject can perform the graph for longer time because of intermittent rest. So rest is increasing the performance while venous occlusion is decreasing the performance. What basic mechanism is there hidden under this? We have already cleared that in the briefing part of this demonstration. Okay, thank you.